आएंगे, अगर सवाल आएंगे तो क्वांटम नंबर सबसे ज्यादा आएंगे, बिकॉज क्वांटम नंबर हैव यूज आफ्टर दिस चैप्टर आल्सो। ठीक है, सो जो सीबीएसई है या नॉट सीबीएसई इन योर केस, स्कूल वाले आई होप इतने मैच्योर होते हैं दैट दे विल आस्क यू क्वेश्चंस व्हिच मैटर। आपको अगर अभी वेवलेंथ फ्रीक्वेंसी नहीं पता रहेगा तो इट विल नॉट मैटर इन द अदर चैप्टर्स, बट अगर आपको क्वांटम नंबर्स नहीं आता रहेगा देन इट विल मैटर इन द अदर चैप्टर्स आल्सो। ओके, and next thing, what do we have till now? Okay, so we did photoelectric effect, right? We did photoelectric effect, and then we did some questions also. Now write the topic. Photoelectric effects है ना, we have some concluding points. उसके लिए you guys remember what is photoelectric effect? Yes or no? वहीं से Bohr's model आएगा, वो कैसे आएगा अभी हम बताते हैं आपको। So photoelectric effect is we strike light, and what happens? What is getting ejected? Tell me, what gets ejected from the middle surface?
Electrons.
Electrons get ejected, and this frequency, it will be having some threshold frequency mu naught. It will be having some threshold frequency mu naught here. Okay, now I will give you a list of metals with their threshold frequency. No, is that work function? Same thing, na? Work function. Okay, so the current model of atom that we are working on right now, we started with the Thomson model, the plum pudding model, in which he said that the electrons are embedded in overall positive charge. Okay, so electrons जो हैं आपके पास embedded हैं and they can come out. But then after Goldfield experiment, we came to know that in an atom we have a very small positively charged nucleus, and the electrons are somewhere here, because when we have we knew that there is some negative charge which is getting ejected, and there is some positive charge because the alpha particles, they striked here and they came back. So we know that there is a very tiny dense positive charge and there are electrons. So obviously if you have some attractive forces like this, then it will be revolving around. So the current scenario we have is this. Okay, so this is the model that you have got from alpha particles by Rutherford. Yeah, so Rutherford ke paas we have this current atomic structure is this. We have a nucleus and then the electrons are revolving. Electrons are revolving. Now the electrons here are attracted by the nucleus. Yes or no? Is that correct? Yes or no? Please tell me. Yes. It is attracted by the nucleus. Okay. And if the attraction will be more, we will be requiring a higher energy of light. The energy of light that is required to eject electron will be higher. If the attraction is lower, then what will be required? Then we will be requiring, if the attraction is lower, we will be requiring energy. The energy of light should also be lower. We will be requiring a lower energy of light. Okay. Now let us look at the work function that we have. Now let us look at the work function here. Aluminium, beryllium, cadmium, calcium, carbon, cesium. Right? So look at these value here. Look at these value here. What is the atomic number of aluminium? Tell me. What is the atomic number of aluminium? What is the atomic number of aluminium? अरे क्या हो गया?
13.
हाँ, 13. Atomic number of beryllium?
4.
Atomic 4. Okay. Now, if you have count the number of protons, then this will be having 13 protons, and this beryllium will be having 4 protons. That means if I look at the aluminium nucleus, it will be having 13 positive charge. Now, we are looking at what? We are looking at the model that was given by Rutherford. This 13 positive charge, it is attracting the electron. And if I look at the beryllium atom, then I have 4 positive charge in the nucleus, and it is attracting the electron that we have on the beryllium atom. Now, if I look at the charges of aluminium and beryllium, then what do you think? Which should be having more force of attraction? Aluminium ज़्यादा अच्छे से attract करेगा electron को या beryllium ज़्यादा अच्छे से attract करेगा? Tell me. Which will attract? Beryllium ज़्यादा अच्छे से attract करेगा? क्यों? Why?
Less number of electrons.
Less number of electrons. तो उससे क्या होगा?
Less number of protons.
तो प्रोटॉन कम है तो
the electrons are closer to the nucleus.
नहीं, क्लोजर की तो बात ही नहीं है. अभी हम लोग को क्या पता? हम लोग क्या पता कि कौन क्लोज है कौन दूर है, राइट? आप तो 9th क्लास का बैगेज लेके आ रहे हैं ना, तो आपको KLM हिमसेल्फ पता है, तो आप उस हिसाब से सोच रहे हैं. लेकिन बट थिंक इन द टर्म्स ऑफ हाउ द साइंटिस्ट वुड हैव लुक्ड एट दिस पर्टिकुलर केस कि you have 13 positive charge and there is electrons. So 13 positive charge, obviously they are going to attract the electron more effectively, yes or no, compared to 4 positive charge. If I have more positive charge, then there will be attracting more negative charge, yes or no, Aisha Iram?
Yes.
Right. So now there was a conflict. There was a conflict that aluminium, which has 13 positive charge, it is attracting electrons. It should be attracting electrons with a higher power, and its work function should be higher. That means it should be requiring more energy in order to give photoelectric effect. But what we are seeing that beryllium is giving, beryllium is showing is requiring more work function or more energy in order to show photoelectric effect. Then it hit Bohr that there must be a case of distance also here. That means the electron must be in different shells. And then he came up, the only logical explanation he said that was, if as we increase the electrons, they are added in different shells. They are added in different shells. So now you understand how this idea of shells came into being? Yes or no, tell me. Shells का मतलब समझ में आ रहा है ना? That they are now the only logical explanation you will give that कि aluminium का electron दूर है और beryllium का electron नजदीक है. That is the conclusion that you can draw from these numbers. Yes or no, Aisha and Arab?
Yes.
Nice. Viram, what about you?
Yes.
Yes, no. So now we have come to the conclusion of atomic structure. Started with plum pudding model, that is why from the cathode ray experiment of discharge tube. Then we went to the alpha particles. In alpha particles, we saw that, okay, fine. From the big atom with overall positive charge and some electrons embedded, we came into very densely packed positive charge nucleus and the electrons revolving around the nucleus. And then after that, we came to the Bohr's model, that is saying that, yeah, correct, the positive charge nucleus is present, but the electrons are present in different orbits. Okay, they are present in different orbits. And as the electrons move away from the nucleus, the attractive force decreases. Okay, so please write now Bohr's model of atom. Bohr's model of atom. Electron is revolving in circular path around the nucleus. Electron is revolving in circular path around the nucleus called orbit. That means this circular path is called orbit, or it is known as shell, or it is known as energy level. Next, the electron is present in the electron. Wait a second. Right, if the electron is present, if the electron is present, if the electron is present in particular orbit, then it can neither radiate, energy nor absorb energy. So the energy of each orbit is fixed. Okay, write this fast. I will explain what does this mean. Done? You wrote this down? Iram and Aisha? If the electron is present, write it. Okay, आराम से लिखिए. Done? लिख लिया आप लोगों ने?
Yes.
Yeah, okay, fine. Now you must be thinking, sir, क्या बात कर रहे हैं आप? Radiate मतलब energy तो वो absorb कर सकता है, electron क्यों नहीं कर सकता? Yeah, it can absorb energy, but as soon as it will absorb energy, it will jump to another shell. It will jump to another shell, right? If the electron is present in one particular orbit, for example, if it is present here, it is present here. Now let me see. नहीं, यहाँ पे नहीं, इसको बीच में रखते हैं, so I can talk about both radiation and absorption. If the electron is present here, okay, and if I give it energy in the form of light, then what will happen? If I give it appropriate energy, then it will jump to this shell. Okay, it will jump to this shell. But if the electron sees that this shell is vacant and it wants to jump here, as soon as the electron will jump here, it will radiate energy. It will radiate energy. So electron can radiate energy and can absorb energy, but not being in the same orbit. As soon as it will absorb energy, it will jump to another orbit. If it radiates energy, it will level down. So level up hoga if it is getting energy. It's like status. यहाँ पे एक status है, यहाँ पे दूसरा status है. Okay, status in the society. If you get more money, being completely capitalistic, if you get more money, your status will increase. And as soon as you go down, अगर status गिरता कब है? When you have lost money, or even if you get down into the status, you will lose money. Okay, energy मिलता है electron को, so it gets up and it levels up. If electron is leveling down, then it will radiate energy. That means being in one orbit and electron, he wants to get energy and be in the same orbit, that is not possible. Electron wants to be in the same orbit and lose energy, that is also not possible. Okay, that is also not possible. Is this clear? Yes or no? Please tell me. All of you got this? Yes or no? Aisha, Iram?
Yes.
Okay. Now, right next. That is why each and every orbit, it will have some fixed energy. Okay? It will have some fixed energy. Right, next. Energy of electron changes if it goes from one orbit to another orbit. One orbit or to another orbit. Right, next. The transition of electron takes place from one orbit to another orbit if the energy of final state minus the energy of initial orbit, it is equal to h into nu. So whatever frequency of light you are giving, that energy should be equal to the difference in those two orbits. Okay, it should be equal to the difference in those two orbits. Done, yes or no, please tell me. Done.
Yes.
All right, next. Do you know this two terms, centrifugal force and centripetal force? Yes or no?
No.
No. So whenever you have something revolving around a nucleus, okay, around a focus, आप ये भी imagine कर सकते हैं that you have a long rope, not a long rope, average length rope, and you have tied stone at one end and you are revolving it like this. Okay, you're revolving it like this. Then there is one force of attraction, one force which is keeping this, है ना, ये rope जो है आपका, that force is there and it is keeping it in that particular orbit, right? It is keeping in that particular orbit. And there is also one more force which is letting it move in this direction tangentially. अगर आप छोड़िएगा तो ये सीधा ऐसे जाएगा, गोल गोल नहीं घूमता रहेगा, right? If you will just leave at once, then it will go tangentially. So there is always this one type of force which is here. So there are two forces which are acting. एक force ऐसा है जो क्या कर रहा है आपको, which is keeping the stone that you have here, which is keeping the stone in the same orbit, which is keeping this in the same orbit. So एक force इधर हो रहा है और एक force आपका लग रहा है tangentially this side. Okay, just getting tangentially this side. Now this force here that we have, which is coming inside, it is known as centripetal force, and this force which is going outside, it is known as centrifugal force. And they should be balanced. They should be balanced. Let me tell you why. If the inward force, that is centripetal, this is centrifugal force. Fugacity का मतलब होता है भाग जाना. Fugacity का मतलब होता है भाग जाना. That is why centrifugal force is there. If the centripetal force increases, if the centripetal force is higher than centrifugal force, then the stone will come a bit closer to your hand. Yes or no? If the centripetal force increases, yes or no? Tell me. जो inward pulling force है वो अगर बढ़ जाएगा, then the stone will come a bit closer. It will come a bit closer. Yes or no, Aisha? Iram? नहीं.
Yes.
Doesn't make sense. हाँ ना तो बोलिए. Okay, fine. And if the centrifugal force increases, then this particular stone, it will get a bit away, right? It will get a bit away. And the same thing is going to happen in the atomic structure with electrons also. Okay, so you write here the force of attraction between nucleus and electron must be balanced by centrifugal
So-
force. हाँ बताइए.
The centripetal force is also the force between sun and the earth, right?
या करेक्ट. जो भी अगर रिवॉल्व कहीं पे भी रिवॉल्व हो रहा है कोई चीज ना, तो you have a focus and then you have the complete orbit. So the one which is getting, the one which is orbiting around something, it will be getting some kind of centripetal force. आपने पढ़ा होगा, that is why I asked centripetal and centrifugal. I think you must have learned this in, जब gravity सबसे पहली बार पढ़ा होगा आपने, then you must have heard this term centrifugal and centripetal. नहीं
Yeah.
है ना? Centrifugal force. Okay, so balance by centrifugal force. What I'm trying to say is centripetal force should be equal to centrifugal force. This centripetal force is what? It is the Coulombic force or electrostatic force, because we have positive charge and negative charge. This force is Coulombic force. Please write Coulombic force. And this centrifugal force is the plain simple centrifugal force that we have, mv square upon r square. Okay, mv square upon r square. Please write what is Coulombic force. Coulombic force. Gravitational force of attraction आप लोगों ने पढ़ा है? Yes or no? Tell me. Have you read about gravitational force of attraction?
Yes.
Okay.
Yes.
So what is the formula G? What is the formula? The force of gravity between two objects m1 m2. क्या होता है?
G m1 m2 by r square.
करेक्ट,
Right?
एकदम सही है. या करेक्ट, एकदम सही है, बिल्कुल सही है. आयशा, you remember this? No.
Yes, I remember.
Okay. Very similar to this is our Coulombic force of attraction also. Okay, it is also Coulombic force of attraction. Now, what will be the Coulombic force of attraction? Coulombic force of attraction में आपके पास एक तो positive charge है, right? This positive charge is what? It is the number of protons that we represent by Z, जो atomic number होता है आपका, and then we have the electron. Each and every electron will face different force because they are a certain distance away from the nucleus. Okay, they are certain distance away from the nucleus. Now, Coulombic force is written as K, G मान लीजिए आप इसको, Q1, Q2, M1, M2 की तरह upon R square. सही है? Yes or no?
Yes.
Okay. Now here K, what is Q1? Q1 को हम ले लेते हैं whatever the charge is on electron. Okay, the charge on electron into, it will be into Z into the number of electrons. ठीक है? Because the charge on one proton is equal to the charge on one electron. है ना? The charge on one proton is equal to the charge on one electron in magnitude. They only differ in signs. They only differ in what? They only differ in signs. That is why we have E for electron, and this Z into E is for the protons, divided by R square. Divided by R square. इसमें आपके पास क्या आ जाएगा? This will be equal to K Z E square upon R square. E square upon R square. Let me know when you are done writing. Let me know when you are done writing.
Sir,
Done, yes or no? Done, na? Okay, fine. Now, the centrifugal force is equal to mv square upon r square. Now, this should be equal to this Coulombic force. Okay, this should be equal to this Coulombic force here. Okay. So, right, k ze square upon r square should be equal to m v square upon r square. So from here, what you are going to get? From here, you are going to get the v square of v square किसके बराबर हो जाएगा? Wait. एक चीज गलती होगी. Wait a second. It will be mv square upon r, not r square. Okay. Yeah, mv square upon r. This will be equal to kz into r square upon r. So r here, r will be left, and v square will be equal to k upon mr. Just make a correction here. mv square upon r divided by mv square upon r, which will be equal to kz square upon r square. V square will be equal to kz square upon mr. Done.
yes, done.
Okay. Now, another thing that Bohr postulated here, okay, he did not give any explanation. Its explanation was later on given by, just on the basis of mathematical results. He told that is right. Out of various orbits, electron can revolve only. Electron can revolve only in that circular orbit. Whose angular momentum is an integral multiple of h upon 2 pi. So what is momentum? Mass into velocity is momentum. Angular momentum, you just multiply this with r. R is what? R is the distance between nucleus and electron. MVR, it should be equal to integral multiple. That means n into h upon 2 pi. Okay, n is equal to h upon 2 pi. Now here n should be equal to 1, 2, 3, and so on. That means what he was trying to say, he was constructing the radius of these atoms. Okay, he was saying that here, what will be V equal to? V will be equal to how much? V will be equal to nh upon 2 pi, nh upon 2 pi mr, yes or no? nh upon 2 pi mr. Okay, and v square will be equal to n square h square 4 pi square m square r square. Okay.
Yes.
Okay. Now what we have seen, we have just seen that this whole thing, it is equal to what? It is equal to v square is equal to k into z e square upon mr, right? So we can write v square is equal to kz e square kz e square upon mr m square h square upon 4 pi square m square r square. You can eliminate a few things and then you will get the, you can eliminate a few things from here. You can eliminate mr. So here you will get also mr. You will get n square h square upon 4 pi mr. This is equal to kz e square. Further, what I will do, I will write r is equal to n square h square upon pi ka square होगा, okay, it is again pi square 4 pi square m into k into z into e square. Done all of you, yes or no? Please tell me. Done.
Yes.
Okay. So from here you will write for hydrogen z is equal to 1. Okay. And the k, that is dielectric constant that we take, it is also equal to 1 unity. Okay. So for all of the metal, all of the atoms, because between the positive and negative charge, we don't have any dielectric constant k that is there. So it is always taken as 1 generally. And r will be equal to, for hydrogen atom, z is equal to 1. K will be always equal to 1 for whatever atom you are going to take. So it will be equal to n square h square upon 4 pi square m e square. Okay. Now, if any, now what he did was, he was saying that you put the value 1 and you will get the radius of first orbit. You put the value 2 here, you will get the radius of second orbit. You put the value 3 here, you will get the radius of third orbit. Okay, so he was trying to say this thing from this particular derivation. It's giving me radius of nth orbit. Then all of you, yes or no? चले आगे बढ़े.
हाँ.
Aisha. चलिए.
Yes.
Right, next. Note. Bohr's orbit is also called stationary orbit, because electron is moving in circular paths of fixed energy. And since the energy is not changing, that is what is known as stationary orbit. Also, this model is only applicable for hydrogen, only applicable for hydrogen atom or hydrogen-like atom, that is one electron system. And I will tell you what is the reason. See, Bohr, while he was discussing and he was trying to tell about the things which are present in photoelectric effect and the work function that he got, he was able to say that yes, fine, we will have different shells, but mathematically he was only telling about one electron system, because if I have one electron, then I have to deal with only one force of attraction, only one force, that is the positive force, and the positive charge and negative charge, they will be attracting each other. That is the only force that I have to deal with. But as soon as I increase the number of electrons, now these two electrons, they will have some repulsion. Now mathematically treating the repulsions of electron, it is very difficult, and that is why this Bohr model is only applicable for what? Only applicable for hydrogen atom. Now we extrapolate and we say things such that Bohr model is applicable for all of these atoms. Qualitatively, yes. Quantitatively, mathematically, no. Mathematically, he is restricted to only one force, that is between the positive charge and the negative charge, so that the math is easy. And you can see this easy math itself is very hard. Yes or no? Can all of you see that this easy math itself is very hard? And if you incorporate the repulsion, then it will get much and much tougher. That is why he did not incorporate repulsion. It was not possible to incorporate for the repulsion. And mathematically, he treated only hydrogen-like atoms. That means those atoms which contain only one electron. So the atoms which can contain one electron, they are hydrogen. Then you can also have what? You can also have helium positive. You can also have lithium positive. Sorry, lithium 2 positive ho jayega. You can have beryllium 3 positive. And so on, you can go on till sodium 10 positive and further also. The only thing is that I have to bring down the force to 1. The force or interaction between the particles should be only one interaction, attractive interaction. I don't want to deal with the repulsions. In attraction only, it is enough difficult. I don't want to deal with the repulsions. So qualitatively, it is applicable for all of the systems, but mathematically, quantitatively, it is applicable only for hydrogen-like systems, one electron system. Is that clear? Yes or no? Please send me. Aisha and Aram.
Yes.
Yes.
बोर का दुख और दर्द समझ में आ रहा है कि नहीं आ रहा है, ये बताइए आप.
आ रहा है.
वेरी गुड, ये होना चाहिए. Done everyone? Yes or no? Please tell me. इसको लिखिए फिर आगे करते हैं. Done? Okay. Now we'll write some mathematical conclusions from Bohr model. Right, mathematical analysis. So first thing is the radius of orbit. We have seen that the radius of orbit, it is equal to what? Tell me. अभी लिखा था हमने n स्क्वायर h स्क्वायर अपॉन 4 पाई स्क्वायर, अरे बोलिए तो, n स्क्वायर h स्क्वायर अपॉन 4 पाई स्क्वायर
m k z
n स्क्वायर h स्क्वायर अपॉन 4 पाई स्क्वायर m e स्क्वायर. Correct? Yes or no?
Yes.
Right. This was for hydrogen. Okay. This was for hydrogen. And what you can write? This is for hydrogen. And in general, Rn is equal to n square h square upon 4 pi square m e square z. Okay. So if you have lithium positive, or sorry, if you have lithium 2 positive, helium positive, then वहाँ पे तो number of proton differ करेंगे. So this is for hydrogen like atoms. Okay, for hydrogen like atoms. Now, when I get this whole thing, तो यहाँ पे आपको दिख रहा होगा there are many constants here, right? So if I look here, h square is a constant, 4 is a constant, pi square is a constant, mass of electron is a constant, charge of electron is a constant, z can be changing. So all of these part is constant, right? All of this part is constant, and this whole constant, it is equal to 0.529. Now what is remaining? Into n square upon z. ठीक है, अब कांस्टेंट होंगे तो कांस्टेंट में यूनिट्स भी होते हैं, and you are going to get this radius of nth orbital, and you will get this in terms of angstrom. ठीक है, so आप इसको याद कर लीजिए आप, है ना, सॉल्व करने के लिए आपके पास ये वाला हो. Done? Yes or no? Tell me.
Yes.
No. जल्दी लिखिए.
They're done.
Okay. Right. The energy of electron. Second thing discussed was energy of electron. Okay. So when the electron is revolving, so when the electron is revolving, it will have some kinetic energy and it will have some potential energy due to the attractive force, है ना. जब भी force लगते रहता है किसी चीज पे, for example, if you have some stone above the ground, then there will be potential energy, right? So it is getting attracted. तो यहाँ पे क्या आपके पास potential energy है. Similarly, it will be having kinetic energy plus potential energy. So we will write total energy, will be equal to the kinetic energy of electron plus the potential energy of electron plus the potential energy of electron. Okay. Now, this kinetic energy that we have here and potential energy that we have here. If you remember from last time, we had mv square upon r. This was equal to how much? K. बताइए. K z e square upon r square. ये था हमारे पास, yes or no? Centripetal and centrifugal से, है ना. अब इसमें हाफ मल्टीप्लाई कीजिए, इधर भी हाफ मल्टीप्लाई कर दीजिए, गेट दिस एज हाफ mv square. Okay, and you can eliminate this r with this r square here. ठीक है, सो यहाँ पे आपके पास हाफ mv square बच गया, and here we have k ze square upon 2 into r. Yes or no, please tell me.
Yes.
Yes, okay. Now this is a half mv square. What is this? This is kinetic energy. It will be equal to k ze square upon 2r. Okay, and what is the potential energy? Potential energy will be equal to k ze square upon r square. अब यहाँ पे potential energy में ना I will give a negative sign, and I will tell you why the negative sign is there. Negative sign, it represents attractive force. Okay, so whenever you have Coulombic force of attraction, तो देखिए, if I will have positive and positive, they will repel, है ना? They will repel, and the charge होगा positive into positive will be also equal to what? Positive, right? So this is the energy I'm writing. Energy यहाँ पे, and here are the Q1, Q2. Okay, if I have positive and negative, then there will be attraction, और आपके पास जो energy आएगा Q1, Q2 क्या हो जाएगा? Negative हो जाएगा. And if I have, let us say, negative and positive, then also there will be attraction, and this energy will be what? Q1 into Q2 will be equal to negative. If I have negative and negative, then it is going to be, multiplication will be positive and the force will be repulsive. I hope you understand that the potential energy that we have between the two charges will be minus kz e square upon r square. Yes or no? Tell me.
Yes.
ठीक है, अच्छा अब आप बोलिएगा तो सर आपने सेंट्रीपेटल फोर्स में क्यों नहीं लिया था नेगेटिव? सेंट्रीपेटल फोर्स और सेंट्रीफ्यूगल फोर्स जो है, उन दोनों में तो हमको पता है, दोनों का डायरेक्शन पहले से ही पता है कि दे आर डिफरेंट. यस और नो? एक आपका अंदर की तरफ खींच रहा है, एक आपका बाहर की तरफ खींच रहा है, राइट? नाउ व्हेन वी ऑलरेडी नो दैट द डायरेक्शंस आर अपोजिट, वी जस्ट हैव टू बैलेंस द मैग्नीट्यूड ऑफ फोर्स, कि जो आपके पास अंदर की तरफ खींच रहा है that should be equal to जो आपको बाहर की तरफ खींच रहा है. So the magnitude matters when we are talking about centripetal force and centrifugal force. When we talk about the pure potential energy, है ना, अब यहाँ पे देखिए टर्म ही चेंज हो गया. We have the potential energy. Now potential energy means you have to take into consideration whether it is repulsive or it is attractive. So it is attractive in this case, that is why it will be having minus kz e square upon r square. Clear है Aisha and Iram?
Yes.
Okay. Now total energy will be equal to kinetic energy plus potential energy. Kinetic energy will be kz e square upon 2r, kz e square upon 2r minus, अच्छा एक चीज, सॉरी एक चीज आपको ये रह गया, दैट वाज आल्सो फोर्स, है ना, और ये क्या है आपका? एनर्जी है, राइट? फोर्स एंड दिस इज व्हाट? दिस इज एनर्जी. सो इन एनर्जी यू जस्ट हैव दिस r स्क्वायर नहीं होता है यहाँ पे, सिर्फ और सिर्फ r होता है. ओके, when you are going from force to energy, it will be minus kz e square upon r. That is the only distance between these two things. And minus kinetic energy plus potential energy क्या है आपका? Minus kz e square upon r. ठीक है, so आपको दिख रहा होगा कि everything is common. I can take k z e square upon r common, और आपके पास क्या आ जाएगा? 1/2 minus 1. So this will be equal to minus half. So minus half will be what? Minus k z e square upon r upon 2r हो जाएगा, है ना? Half minus 1 will be equal to minus half, है ना? It will be what? Minus kz e square upon 2r. This is the total energy. लिख लिया आप लोगों ने, ऐसा ना टेल मी?
Yes.
ओके,
सर
बताइए।
सर ये फॉर्मूलाज हम लोग न्यूमेरिकल्स में यूज करेंगे?
नहीं, आप लोग नहीं यूज कीजिएगा, कोई नहीं पूछने वाला आप लोगों से। ओके, बट इफ यू आर गोइंग टू गिव एंट्रेंस एग्जामिनेशन देन
ये
वहां
हम
पे
पढ़ते
आएगा।
रहे,
हाँ,
तो ये हम लोगों को पढ़ना नहीं है ये?
नहीं, बट इफ यू गिव एंट्रेंस एग्जामिनेशन देन वहां पे पूछ सकते हैं। एंड ऑल ऑफ दीज थिंग्स दैट यू आर गोइंग टू लर्न, उसके बाद जो कंक्लूजन निकालेंगे ना एनर्जीज का, द टोटल एनर्जी, देन आई विल गिव यू दिस फॉर्मूला। जैसे रेडियस का फॉर्मूला दिया ना हमने, ये वाला है ना, तो ये आपको इस्तेमाल होगा। ठीक है, यू विल बी आस्क्ड टू कैलकुलेट द रेडियस। तो हम क्या डायरेक्ट दे देते हैं आपको, ये रट लो आप। हाँ आयशा?
नहीं।
नहीं ना, सो सेम थिंग टोटल एनर्जी का। अभी ये सारा पार्ट जो है आपसे कोई डेरिवेशन नहीं कोई पूछने वाला, बट टोटल एनर्जी ये आपके पास वैल्यू आई है, राइट? एंड देन इफ यू सब्स्टिट्यूट द वैल्यू ऑफ आर हियर, आर की वैल्यू क्या होती है अगेन, n² अपॉन 2πr², me square z, then you will put the value here and you will get some equation there. उसका जो न्यूमेरिकल वैल्यू है वो हम आपको लिखेंगे, that you will use when you are doing numericals. ठीक है, ये डेरिवेशन है बस समझने के लिए कि कहाँ से आ रहे हैं चीजें। ओके,
ये टेस्ट में आप ये सब नहीं पूछेंगे?
नहीं, टेस्ट में ये डेरिवेशन नहीं पूछेंगे हम, लेकिन कंक्लूजन्स याद करने हैं आपको। जैसे रेडियस है ना, तो रेडियस में आपको ये छोटा सा फॉर्मूला याद करना पड़ेगा। उसके बाद अभी टोटल एनर्जी के फॉर्मूला हम लिखा देंगे, उसको आपको याद करना पड़ेगा। ठीक है आयशा?
ओके ओके सर।
हम्म, ओके। सो आफ्टर, अब देखिए यहाँ पे टोटल एनर्जी जो आएगा ना, दिस विल बी इक्वल टू माइनस kz अपॉन 2 इंटू आर की वैल्यू क्या होती है, आर की वैल्यू इट इज इक्वल टू हाउ मच, n² अपॉन 4π² me²z, राइट? सो व्हेन यू विल सब्स्टिट्यूट ऑल ऑफ दोस वैल्यूज, ठीक है, व्हेन यू विल सब्स्टिट्यूट ऑल ऑफ दोस वैल्यूज, हम यहाँ पे सब्स्टिट्यूट करके नहीं दिखा रहे हैं आपको, ठीक है? आप फिर घबरा जाइएगा सर ये भी पूछिएगा क्या। जस्ट राइट एनर्जी ऑफ nth ऑर्बिटल विल बी इक्वल टू माइनस 13.6 z² upon n². This will be electron volt per atom. Okay, but if you change the units, energy of nth orbital in kilojoule per mole, this will be equal to minus 1312 upon n² into z² kilojoule per mole. लिखते हैं क्या इसको यहाँ पे, टू इंटू आर को क्या है, ये 1/r है, तो इट विल बी व्हाट, n² h² है ना। अब जो यहाँ डिनोमिनेटर ऑफ डिनोमिनेटर इज व्हाट, इट इज न्यूमरेटर, विल बी इक्वल टू 4π² me²z, है ना। तो ये देखिए यहाँ पे आपके पास क्या हो जा रहा है, z का स्क्वायर हो जा रहा है, z² इज कमिंग हियर एंड ऑल ऑफ द अदर थिंग्स आर कांस्टेंट। तो जो कांस्टेंट हम उसको रेट में लिख देते हैं, k इज कांस्टेंट, this 2 is constant, the e² is constant, this 4 is constant, this pi is constant, this n is constant, नहीं n constant नहीं है, h constant है आपके पास, m is constant, e is constant, ठीक है। so you have just z into z² अब नीचे n² है, तो z² upon n², and these are the values of constant here, ठीक है। तो आपके पास ये दो ना इक्वेशन है, ये इंपॉर्टेंट है, इससे सवाल आ सकते हैं, इससे सवाल पूछ भी सकते हैं। ओके, लिख लिया आप लोगों ने ये सुनो प्लीज मी।
यस सर।
ठीक है, अच्छा अब ये बताइए E इज इक्वल टू क्या है, सम वैल्यू, आई कैन से दैट E is proportional to 1 upon n square, है ना, 1 upon n square. Now E will be maximum when n is equal to what, infinity, yes or no? जब जैसे जैसे n की वैल्यू बढ़ते जाएगी एनर्जी का वैल्यू क्या होता जाएगा, बढ़ता जाएगा, yes or no, tell me.
Yes.
Right, now if n is equal to infinity, if n is equal to infinity, energy what, it will be equal to 0, yes or no? है कि नहीं, बताइए आप यहाँ पे इंफिनिटी रख दीजिए, जो इलेक्ट्रॉन की एनर्जी आएगी वो 0 हो जाएगी, करेक्ट? yes or no, आयशा, इरम?
सर रिपीट करिएगा।
फिर कैसे?
अरे अरे व्हाट एवर 100 अपॉन इंफिनिटी कितना होता है, एनीथिंग अपॉन इंफिनिटी इज इक्वल टू हाउ मच,
0.
0 ना, तो वही तो कह रहे हैं हम, बस आया समझ है?
Yeah.
अच्छा नहीं आया समझ आयशा को?
नहीं।
अच्छा कैलकुलेटर है आपके पास, डू यू हैव अ कैलकुलेटर?
फोन में।
हाँ फोन में है ना, सो उसका देखिए 10 टू द पावर मैक्सिमम कितना जा सकता है, या फिर 99 टू द पावर कितना जा सकता है, कुछ भी देखिए एक बार, हाउ मच कैन इट गो मैक्सिमम। 1 अपॉन 10 इज इक्वल टू हाउ मच, 0.1। इसी तरह देखिए 1 अपॉन 100 इज इक्वल टू 0.01। अब जैसे डिनोमिनेटर इट विल रीच इंफिनिटी, ये जो टोटल वैल्यू है दैट विल बिकम 0 ना, 0 के नजदीक चला जाता है। अरे भाई साहब ऐसा लग रहा है पहली बार सुन रही हैं आप, समझ आ गया?
यस।
अरे भूल कैसे जाते हो आप लोग, 11th 12th क्लास में आप लोग आते हैं तो फिर 6th 7th भूल जाते हैं क्या, मतलब एक बच्चे एक दिन पूछ रहा था ऐसे कुछ तो 1/2 था, और उसके बाद इधर कुछ 1/4 टाइप से था, तो हमने इज इक्वल टू लिखा यहाँ पे ऐसे 2 + 1/4, तो बोलता सर ये 4 कैसे हो गए, तो 2 था ना। अब आप लोगों को समझ में आया कि नहीं आया, ये आयशा निरम आया? ठीक है
आया।
है ना, 7th 8th क्लास मतलब एलसीएम सब भूल जाते हैं बच्चे। ओके, सो दैट आल्सो मेक सेंस, आई होप यू अंडरस्टैंड। n इज इक्वल टू इंफिनिटी कब होगा, जब इलेक्ट्रॉन जो है एटम का जो न्यूक्लियस है उसके इन्फ्लुएंस से ही बिल्कुल बाहर हो चुका है, राइट? सो नाउ दिस electron is not even getting attracted by this particular nucleus, right? That is why it is having energy which is equal to 0, yes or no, correct?
यस।
Okay, तो यहां से आपके पास एक पॉइंट लिखिए रिमार्क्स में, the maximum energy of electron is 0, is 0. It means the electron is present at infinite distance away from nucleus. Just away from nucleus. अब देखते हैं हम लोग, like what will be the energy required, okay, right here, the amount of energy required to remove the electron from ground state to infinity is called ionization energy. Okay, ionization energy. Now हम लोगों ने देखा था that whatever energy that is required will be equal to the E final minus E initial, है ना? तो E final क्या है आपका? E final is your E infinity minus what is your E initial? E initial is equal to what? E initial is equal to E, और जो भी है आपके पास whatever your Z is there and whatever your N is. Okay, so if I talk about the first orbit, then the energy required to remove the electron will be E infinity क्या होगा? 0 minus En will be equal to how much? अभी हमने देखा था एक फॉर्मूला minus 13.6 Z square upon N square, and here what we have taken, N is equal to 1. This will be what? Electron volts per atom. अगर एक atom को हम निकाल रहे हैं, here what we have taken, N is equal to 1. Now you can see that this energy is coming what? As positive. 13.6 Z square electron volt is the energy required to remove the electron from first orbit to infinity. This is the energy required. This is the ionization energy. लिख लिया आप लोगों ने ये सारा प्लीज मी?
Yes.
ओके, दो डेफिनेशन यहाँ पे लिखे, ग्राउंड स्टेट एंड एक्साइटेड स्टेट. Right? If electron is present in first orbit, then it is called ground state. Why? Because this is the lowest energy state. Lowest energy state. Okay. There's another word which is excited state. If electron is present in any orbit other than ground state is called excited state. ठीक है, ये बताइए फर्स्ट एक्साइटेड स्टेट कौन सा ऑर्बिट होगा? Tell me, what will be the first excited state? What will be the value of n? For first,
1.
अरे
0,
बिहारी
0.
जीरो 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 कौन सा स्टेट? ऑर्बिट होता है क्या कोई? जीरो कौन सा ऑर्बिट होगा?
S.
अरे
SPD.
ऑर्बिट, ऑर्बिट आयशा कुछ भी बोलते जा रहे हैं, सारा बस मतलब वर्ड्स का कलेक्शन है इनके पास, बोलते जा रहे हैं ये होगा ये होगा। ध्यान से सुनिए, व्हाट इज एक्साइटेड स्टेट आयशा एंड अरम? if electron is present in any orbit other than what?
Ground state.
What is ground state? What is ground state?
First order.
Lowest energy state.
हाँ तो कौन सा होता है? फर्स्ट ऑर्बिट होता है वो, है ना? राइट आयशा?
हाँ,
हाँ तो फर्स्ट के अलावा और कौन कौन से ऑर्बिट हैं हमारे पास? व्हाट आर द अदर ऑर्बिट्स?
2, 3.
फर्स्ट के बाद और
2, 3, 4.
ठीक है ना? जीरो तो ऑर्बिट नहीं होता ना, एन के वैल्यू जीरो नहीं हो सकता, राइट आयशा? यस आयशा
हो
इरम?
सकता है ना?
अरे
नहीं होता.
प्रिंसिपल क्वांटम नंबर खत्म हो गया, जीरो हो सकता है क्या एन की वैल्यू?
अच्छा,
N?
नहीं.
हाँ अभी हम गुस्सा हो जा रहे हैं, पानी पीने दीजिए हमें। तो अब बचा क्या? एक के बाद पहला क्या हो? सेकंड होगा ना?
Second.
फर्स्ट एक्साइटेड स्टेट विल बी द सेकंड ऑर्बिट, राइट? ये ध्यान रखिएगा, थोड़ा सा यहाँ पे वर्ड प्ले कर देते हैं टीचर्स। इट विल बी 2, है ना? फर्स्ट एक्साइटेड स्टेट, सेकंड एक्साइटेड स्टेट इज इक्वल टू, इसमें n की वैल्यू क्या हो जाएगी? 3।
3.
दिख रहा है ना? तो
हाँ.
आपको समझ में आ रहा है ना, कंफ्यूजन हो सकती है बाद में, है ना? ओके
Yes.
so you'll write for ith excited state n will be equal to I plus 1। ठीक है, तो शेल होगा वो आपका क्या होगा? I plus 1 होगा। अगर आपको फिफ्थ एक्साइटेड स्टेट तो n की वैल्यू 6, सेवेंथ एक्साइटेड स्टेट तो n की वैल्यू 8। Done everyone? Yes or no? Please tell me.
Done.
है ना? इसको ध्यान रखिएगा, ये देखिए आयोनाइजेशन एनर्जी है सबके लिए। ओके, दिस इज द आयोनाइजेशन एनर्जी फॉर सबके लिए, इसको ध्यान रखिएगा, दिस इज इंपॉर्टेंट इक्वेशन। Ionization energy for everything. Now you write another thing which is known as separation energy. What is separation energy? The amount of energy required to remove the electron from excited state to infinity. It is known as separation energy. ठीक है, write a question. Ionization energy of He positive। ठीक है, सवाल लिख लिया आप लोगों ने? आयशा निरम?
Yes.
ठीक है, अब आप इस सवाल को देखिएगा, अगर आपने पढ़ाई नहीं करी होती तो आपको लगता है कुछ तो दे दो हमको, कहां से निकालें हम, याद करके आ जाए क्या आयनाइजेशन एनर्जी सबका? यू विल गेट दिस फीलिंग, यस और नो? टेल मी।
Yes.
है ना? मतलब कुछ दिया ही नहीं, समथिंग इज मिसिंग, है ना? समथिंग इज मिसिंग, बट वी नो दैट वी हैव अ फॉर्मूला फॉर आयनाइजेशन एनर्जी, E is equal to what? 13.6 into Z square। ठीक है, यहाँ पे लिखिएगा आयनाइजेशन एनर्जी is equal to 13.6 into Z square इलेक्ट्रॉन वोल्ट। तो ये आपको याद करके आना था। अच्छा, अब इन्होंने क्या इंफॉर्मेशन दिया है? सब याद करके आना था। तो इन्होंने इंफॉर्मेशन दिया है that we have helium atom. Now you will tell me how many protons are there in helium atom? Tell me, helium का एटॉमिक नंबर कितना होता है?
2.
2.
2 है ना, तो Z इज इक्वल टू क्या हो जाएगा, 2 हो जाएगा. यू विल
2.
प्लग इन द वैल्यू 13.6 into 2 square electron volt, which will be equal to 13.6 into 4 electron volt. ठीक है, क्या आ जाएगा आंसर?
$55.4.
55 55 या 54?
55.4.
55.4.
फिर से कीजिए.
सर 55 आ रहा है.
नहीं सर, 54.4.
आयशा, मल्टीप्लाई करें क्या हम? हाँ,
नहीं 54.
ठीक है, 54.4. डन.
Yes, done.
Yes.
चलो, तो आज के लिए इतना ही. ठीक है, द नेक्स्ट क्लास वी विल डू सम मोर क्वेश्चंस, सम मोर क्वेश्चन. और सवाल नहीं, अब थर्सडे ना, हाँ थर्सडे को ही देखेंगे. ठीक है, नाउ इसके बाद आपके पास टॉपिक्स हैं डी ब्रॉगली का हाइपोथेसिस. ओके, तो कंप्लीट बोर मॉडल आज हो गया, क्वालिटेटिव एस्पेक्ट्स भी हो गया, मैथमेटिकल एनालिसिस भी हो गया. डी ब्रॉगली है, डी ब्रॉगली इज इंटरेस्टिंग. देन वी हैव हाइजेनबर्ग अनसर्टेनिटी प्रिंसिपल. आई थिंक किसी को हमने हाइजेनबर्ग